All right, hello and welcome. In this example, we're going to solve for our angle of C, and then we're going to use that to solve for our angle of B, and then that's going to be used to solve for the side of C. Right? And so I'm going to show you how to kind of negotiate through based on what you have in the circuit over here. So you were given that A is equal to 65 millimeters, that C was equal to 84 millimeters, and that the angle of A, this angle over here, was equal to 38 degrees. Right, so they gave us a couple of things here, and immediately we compare things that are diagonal. So we know that angle A and A are going to go together here. Right, so side A and angle A together. And we also know that side C and angle C together are going to go together, and side B and angle B are going to go together. And so that's for the law of sines. We see that over here, right? Sine A has the angle with A, sine B has the angle with B, and sine C is with our side C. So we can use that. That means that we have two portions. We have A, and we also have this bottom one, this C, but we don't know what this top C is. So we can ignore the fact that sine of B is there and say that sine of A over A is equal to sine of C over C, and we can solve out for what this unknown C variable is, and that's what they want right here. Find the angle of C. And so let's do that. Let's use our sine equation and say that we have sine of A over a side of A, and we'll set that equal to our sine of C over side C. Right. So the first thing we need to do is get our angle of C by itself, because that's going to make it easier for us to solve this out. And so we can say that to do that, we need to get rid of this thing on the bottom here. We want this C all by itself. So let's plug in the numbers that we know are here. We can say that A and little a are known values. Sine of 38 degrees for cap A here. That's this one over here. And then we can say that the side A is 65 millimeters. And we know that C is also here too. We know that that is going to be our 84 millimeter. Right, so the only thing we don't know is this C, cap C variable at the top here, and that's going to be this angle of C. And so we can solve for this by multiplying off the bottom number here. If we're dividing 84, then we're going to have to multiply it to both sides to get rid of it. So multiply 84 to both sides. And that's going to give us a new right of the equation. So we can rewrite it and say that we now have, and that's going to eliminate these two, 84 times sine of 38 degrees divided by 65. And that is equal to sine of C. Right? Sine of C is not C by itself yet. We still have one stage to go here. So we can actually take the inverse sine. So if we take this and say that we're actually going to take the sine to the -1 of that, that's going to cancel out both of those signs. So we end up eliminating sine from this side. But we got to do it to the other side too. Right? So we'll take this whole thing and say that we're going to take the sine of -1. And that's going to reset that. That's going to give us C on one side. So I'm going to pull C to the other side here and say that C is equal to sine of -1 times 84 times the sine of 38 degrees over 65. And that's all closed up in that parenthesis. So make sure that you get your parentheses in here. Make sure you're taking the inverse sine of this entire digit out here. And so let's plug this in, because this is going to get our first variable, our C term. So we'll say that we're going to take our inverse sine and open a parenthesis there, it gives us to us. And then we have 84 times the sine of 38. We'll close that parenthesis and divide that by 65. And we'll close this off. And so now we got 52.7. And that is our C side. So our C angle is equal to 52.7 degrees. So we got 38 degrees on one, 52.7 on the other, which means that we can plug in what we know about our triangle. We know that our triangle has a total degrees of 180. It cannot have more than 180 if it's a triangle. And so we can say that we know that we lost 38 degrees in A, and we lost 52.7 degrees in C, and that means that we know what our angle B is equal to. Right? We actually need that, because if we wanted to solve for our side B, we need to use this equation over here. Right? And we'll see that as we go through here, we have A and we have C. We have A times C, we can do that, but we need to have B. Right? So we really need to solve for B in this equation so that we can get into the use of this one so we can solve for side B. So we'll do that. So we know our variables here, so let's send this out and actually just solve out for our B term. We know it's 180 minus 38 minus 52.7, 89.3. And so we can plug that in for our B variable. Now we know that this angle over here is 89.3 degrees. And from there, we can use our law of cosines. Up here, we'll say that we want to solve for B, this term over here, and we technically have the square root on the outside, but we can rearrange that, right? We can say that we can square this, get rid of the 2 on that side there, and that means we have to square root the whole other side here. And so that gives us a B equals value. We can say that our B is equal to the square root of A squared. We know what that is. It's 65, right? 65 squared plus C squared, 84 squared, minus 2 times A, 65, times B, or times C, 84, times the cosine of our B variable, which we just found out was 89.3. We'll plug that into our calculator here. I gotta clear these ones out. See them? And we'll say that that is the square root of 65 squared plus 84 squared minus 2 times 65 times 84. We'll keep going here, times our cosine, so that's automatically done there, 89.3. Right? That means we have 105.5, and that is our side B, 105 millimeters. Right? So B is equal to 105. And so those are our 2 ones, so make sure you circle your answers at the end so that we know where they're at. Where's our other one? That was our side B, 52. All right, if you guys have any other questions, let us know.